AI agents. You hear that term everywhere, right? It's one of the biggest buzzwords in tech. But what's actually real and what's just hype? Well, in this explainer, we're going to break down how they really work, the serious challenges holding them back, and where they're already, changing the game.
So you've probably heard people saying this is the year of AI agents, but some of the biggest names in the field, like OpenAI co-founder Andrej Karpathy, are telling us to think bigger. They're framing this as the decade of agents. So what's the real story here? Are they just an overhyped novelty, or are they really the future of automation? Let's dive in and find out.
First things first, let's get our terms straight. You're definitely familiar with AI assistants. Think ChatGPT. They're what we call reactive. You give them a prompt, they spit back a response. Simple. But AI agents, they're proactive. You give them a goal, and they go off and figure it out on their own. They'll plan, execute a whole series of actions, and even learn and adapt as they go. Honestly, it's the difference between having a helpful co-pilot and a car that drives itself.
Okay, so how in the world do you actually build one of these proactive agents? Well, it turns out there's a surprisingly consistent blueprint that's emerged for how to build their core architecture, no matter what you're using them for.
See, at the heart of pretty much every agent is this really powerful feedback loop. It all kicks off with perceiving the world around it by taking in data. Then, an LLM, the brain, reasons on that data to cook up a plan. Next, the agent acts on that plan using a bunch of different tools. And finally, and this is the key part, it observes what happened. This simple little cycle of perceive, reason, act, observe is what lets an agent learn and tackle incredibly complex problems all by itself. And that standard blueprint really breaks down into three main parts. First, you've got the core engine. That's the brain, almost always an LLM. Then you have tools. Think of these as the agent's hands, letting it actually do things in the digital world. And so critically, you have memory. This is what gives the agent context and, allows it to learn from what it's done before.
But what happens when a problem is just too big for one agent to handle? Well, developers are using two main strategies. The first is a multi-agent system. It's basically a team of specialized agents that work together, like a research agent handing off its findings to a writing agent. The second approach is called a mixture of experts model. You can think of this as one super smart person who happens to be an expert in a bunch of different fields. It's all packed into one LLM, which makes it way more efficient. And this brings us to a really critical debate in how we design these agents. The LLM is the reasoning engine, the planner, right? But for certain high-stakes decisions, especially the ones that involve a lot of structured numerical data, is an LLM really the right tool for the job every single time?
And this slide just perfectly illustrates the argument for a whole different kind of agent. You see, for tasks like deciding on a loan or flagging potential fraud, LLMs can be, pretty unreliable. Their whole black box thing makes them a nightmare to audit. And that's exactly why many systems use specialized decision agents. These guys rely on more traditional machine learning or just clear-cut business rules to make sure you get consistency, transparency, and precision right where it matters most.
All right, let's move on to the practical hurdles. Because, look, building a cool agent is one thing. Deploying it safely and in a way that doesn't break the bank in a real-world business, that is a whole different ballgame. This is exactly where the hype smacks right into the hard reality of actually getting this stuff to work.
Let's kick things off with reliability, because the stakes here are just incredibly high. In IT, for example, a single minute of downtime costs a company, on average, $9,000. So if an autonomous agent messes something up, the financial fallout can be absolutely massive. And that right there is why trust is the single biggest barrier to getting these things adopted.
So making these agents actually viable in the real world really boils down to a three-part strategy. First, you fine-tune the model on your specific data to cut down on errors and costs. Second, you use something called context curation, which is a fancy way of saying you carefully pick only the relevant data to feed it, so it doesn't get confused or start hallucinating. And, probably most importantly, you keep a human in the loop for any high-stakes decision. That's your critical safety net. And because those risks are so real, you can't just build an agent and, let it run wild. No way. Every serious deployment relies on a super rigorous evaluation loop. This means you have to define what success even looks like, test it against real-world data, and really understand the trade-offs, like do you want it to be fast or do you want it to be accurate? And crucially, this whole process keeps going even after it's live, with constant monitoring to make the system better and better over time.
So let's look at where Agentic AI is actually working today. It's not this all-or-nothing kind of technology. Its success really depends entirely on the type of problem it's trying to solve.
A great way to think about this is on a spectrum of maturity. For narrow, really well-defined tasks like writing code or documentation, agents are amazing today. They're incredibly effective. For stuff with a bit more ambiguity, like booking travel based on your personal tastes, they work, but they definitely need a human to supervise. And then for the truly messy, complex problems, like autonomously fixing a brand new IT problem on your laptop, well, that's a vision for the next decade.
And because of this whole maturity spectrum thing, agents are popping up everywhere. In IT and development, they're writing and fixing code. In business operations, they're automating all sorts of routine tasks. They're tackling complex data analysis and even being used to coordinate disaster response. The big takeaway here is that agents are not one-size-fits-all. They are highly specialized tools for very specific problems.
Which, of course, brings us all the way back to our original question. With all this incredible potential on one side and these very real challenges in cost, safety, and reliability on the other, how should we be thinking about AI agents right now?
The most accurate answer is that it's both. For those narrow, well-defined tasks in structured environments, the year of the agent is absolutely here. They are creating tremendous value right this second. But for that grander, more ambitious vision, agents that can reliably and autonomously handle the messy, unpredictable problems of the real world, well, for that, we're just at the very, very beginning of an incredibly exciting and transformative decade.